Assalamualaikum warahmatullahi wabarakatuh. My name is NUR SHAFIKA binti Moideen from Universiti Pendidikan Sultan Idris, and I would like to present my research on identifying the presence of chaos based on variation sediment transport data in Sungai Selangor, Malaysia. Sedimentary solids can be defined as organic matter and inorganic matter which are transferred from one area to another through an erosion process and will be stored in a new location. Erosion is able to move sediment through water, ice and wind. The speed of water flow is a major factor influencing the mobility ability of the resulting sediment. The process of sediment deposition depends on the discharge of the river flow and the speed of the river flow. The higher the river water discharge value and velocity, the higher the amount of sediment transported by the river. The effects of this erosion will eventually cause the river to become shallow and cause flood disaster to occur because the river does not have a systematic and smooth ecological system. So this study focused on the application of a chaotic approach to sediment transport time series data using different numbers of data. This area was chosen because Selangor is an industrial development and construction city in Malaysia, and Sungai Rantau Panjang has experienced pollution of raw water sources causing some water treatment logs to be ordered to stop operating for 24 hours. In Malaysia, the methods that are often used to detect the presence of chaotic cluttered system are the phase-based plot method and Chow method. Both methods have successfully proved the presence of chaotic erratic system in river flow time series data from Adenan and Norani 2015, ozone from Hamid and Norani 2017, sea level from Ali and Hamid 2019, temperature Bahari and Hamid 2019, and carbon monoxide from Ruslan and Hamid 2019. So the objectives of this study is to identify the presence of chaos on the variation of sediment transport data in Sungai Selangor by using the phase-based plot method and Chow method. In methodology, it consists of two stages, which are the first stage are data division using the percentage method. SRP01 is refers to Sungai Rantau Panjang or SAT1. It used of 25% of the whole data, which are 2,100 data. For SRP02, it use of 50% of data. SRP03, it use of 75% of data, and SRP04, it use of 100% of the whole data. For stage 2, we conduct to detect the presence of chaotic antics by using two methods, which are phase-based plot method and Chow method. For data, this study used data from February 2002 until February 2008 that were taken daily. For SRP01 data, it consists of 525 data. For SRP02, it consists of 1,050 data. For SRP03, it consists of 1,575 data. And SRP04, it consists of 2,100 data. So in phase-space reconstruction requires one parameter, which is the parameter tau. In order to find the parameter tau, we need to use average mutual information method. The determination of the value is by using the value of tau obtained by using the average of the mutual information AMI method. For SRP01, it gives the value of tau is 1. For SRP02 and 03, it gives the same value of tau, which is 4. And for SRP04, it gives value of tau is 12. So these are the graph that refers to phase-space plot. All phase-space plots show an identifiable shape. It can therefore be concluded that the sediment transport time series data used are chaotic. For Chow method, there are two steps to do Chow method, which are E1D and E2D. According to Zaim and Hamid, and the saturation value of the value of E1D is chosen between 0.9 to 1.0. So from the table given, we can see that for SRP01, it's saturated at 0.9256 with the value of dimension 4. For SRP02, it's saturated at 0.9033 with the value of dimension 5. And for SRP03, it's saturated at 0.9297 and it gives dimension value of 6. And for SRP04, it's saturated at 0.9076 and it gives the value of dimension D6. So for Chow method using E2D, a dynamic is said to be chaotic if at least one value of E2D is not equal to 1 on the graph. plot of E to D against embedding dimension D. Through the graph E to D, thus you can prove that the data of the sediment transport dynamic system studied is chaotic. In conclusion, the presence of chaotic antiques in the sediment transport time series data according to daily data using 4 different datasets can be detected through both methods, namely phase-space plot method and Chow method. The use of different numbers of data has no effect in identifying the presence of chaotic antiques. The use of a small amount of data is also able to detect the presence of chaotic antiques in the dynamic of the sediment transport. Thus, the construction of a forecasting model using a chaotic approach can be continued for the sediment transport time series data use. Lastly, these are the references that I used for this study. That's all from me. Thank you.